In this course, we will learn how to perform a power glitch to bypass the readout protection of a protected chip. Assuming we have never worked with microcontrollers before, we start by turning on the LED on this device. So we open up our Python shell. We simply use MicroPython to configure the LED as an output pin, and we set the value to 1. That's it. This is how we can turn on the LED. We are now introducing a while loop and we want to toggle the LED right now. And therefore we use the help of the command line to see how to use the uTime library, and then we are waiting for 100 milliseconds to turn it off and wait for 100 milliseconds to turn it on. Let's upload it and there we go. Here's our blinking LED. We're now introducing a MOSFET, which will be discussed during this course. Okay, maybe a short introduction into MOSFETs. So a MOSFET is simply just a high-speed switch. Here we're having an N-channel MOSFET, which means we're connecting the source to the ground of our Raspberry Pi Pico and the drain to the ground of our target board. By applying a positive voltage onto the gate, we are now closing the switch, which means current can flow. By removing the voltage, we are opening the switch, which means the connection gets interrupted. And what the MOSFET is now doing, it's controlling this external LED. So instead of using the internal, we are now using an output pin. We also need some external power supply to not exceed our ampere limit of the output pin. And we have to modify the code as following. We're introducing a new pin, and now we are switching the LED pin to the external pin. We rerun the code, and now we're controlling an external pin. In this case, this LED here. And this is the whole setup that's required to perform the glitch. Here's our external target board, and we have now simply just connected the ground line from our LED before to the ground line of this target board, which means we are controlling the power line of this target board. But we do not want to glitch the core voltage of this board, we want to glitch the voltage of the CPU line. And therefore I have added this single wire to all of these boards. We are changing this cable to this location here, which means we are grounding the core voltage line of the CPU by toggling this pin. So this is the whole schematic of our setup, and we have simply just introduced a few lines for the oscilloscope. If we now switch to the oscilloscope, we can see the yellow line is the core voltage and the blue line is the voltage of the CPU. The moment where this line drops a little bit is the moment where we want to glitch. And if we zoom out a little bit, we can see our glitch is already happening here. We are a little bit too far away from our position. So how can we adjust it? Well, it's very easy. We simply go into this code. This is the whole glitching code, and we adjust this value on the fly. There we go. We are a little bit closer. One more adjustment, setting it to 4600 on the fly. There we have it. Perfect location. Awesome. So we fiddle around the signal to see how the glitch shape looks like, and here we have it. We can see we are a little bit too far off. So if we choose this value a little bit lower, then we should have the perfect glitch timing. The end result looks like the following. Here we're having an Apple AirTag, the old version, which is vulnerable to this type of attack, and I was able to glitch it with the exact same setup shown before. And now instead of redirecting to the Apple domain, it redirects to the trainings I provide this year.